In the alternate form of the definition of the derivative, both of which you have to know, the original definition of the derivative is the more popular one. However, this one also is just as important because there are certain problems where when you're working with the definition of the derivative, one form works better than the other. So instead of where the difference occurs is at the very beginning when you define the two coordinate points. So in this picture, I will start with defining the left as a and the right as x. And so instead of defining it as x and then x plus h, we just have a simple a and x. And so if this function is called f of x, then that means this coordinate point is called f of a, and this coordinate point is called f of x. And so I'd like you to go ahead and hit pause on the video and try to set up for me the slope of the secant line based off of those two coordinate points. So hopefully you've figured out it's f of x minus f of a, change in y over x minus a. And so the idea of the limiting process being added to then make the slope of the tangent line be the derivative, what we're going to do is insert a limit, but instead of letting h go to 0 like in the original definition of the derivative, what we want to do is make this value closer to this value. So we're going to let x approach a and then insert our difference quotient, f of x minus f of a all over x minus a. And those are your two definitions of your derivatives.